Thank you for coming to our panel discussion. I'm Indranil Chakraborty. I'm the product guy with the Google Cloud Platform, focused on IoT, machine learning, and the edge-related stuff as well. So I think we have a pretty good panel here today to really discuss about the next wave of IoT intelligence, particularly as it comes to edge. And well, we've seen many IoT applications which were noteworthy because they can collect data and data from different devices. We want to hear from this panel about how they see edge computing impacting IoT implementation in a new and innovative ways. So we have four of distinguished panelists here today. Willem Sundelbard from Odin Technologies, Sam Nagar from Pixeom, Mark Phillips from Helium, and Soren Knudsen from Intel. I want to make sure that I'm pronouncing your name correct. Knudsen.
Rounding error, no problem.
Great. So without further ado, let's get started. And why don't we start with each one of you spending a couple of minutes just to give an overview about your company and what you do for the benefit of the audience. So Willem, why don't we start with you?
Yeah, great. Hi, everyone. As Indranil said, Willem Sundelbard, co-founder and CEO of Odin Technologies. And we're an end-to-end industrial Internet of Things company. So we have a device that we connect to industrial machinery, collects data, sends to our analytics platform where we help manufacturers really eliminate their waste. So solving quality issues, optimizing processing of components, solving machine failures. And we really saw kind of two problems in manufacturing. One was it's usually really difficult to actually get access to good, clean, complete data on how the process works. And then it's really hard to understand that data and make sense of it. So we set out to solve both of those problems. And so there's a lot of interesting edge challenges there, which I'm sure we'll get into. But obviously, if it's manufacturing and you're talking about alerting, control, machine learning, it is mission critical in the end. So that's kind of where our push to the edge comes from.
Great. Sam?
Hi, everyone. I'm Sam Nagar, CEO of Pixeom. And my company makes an edge computing platform that allows our customers and developers to deploy edge versions of Google Cloud services on-premise. These are containerized versions that host the same APIs you find in the public cloud and enables offline operation of a cloud-native application that was built for Google Cloud. We are in also a number of industries, smart retail, manufacturing, surveillance and security, and many more.
Great. Mark?
Thank you. So my name is Mark Phillips. I run business development and customer success for a company called Helium. So Helium was founded towards the middle of 2013 to basically give people a better physical wireless network for device and sensor data. And over the past, I guess, 5 years at this point, we really haven't seen the situation change for companies building connected devices. And we're going after smaller data, kind of long-range, highly secure sort of applications where people need to put a sensor in the field and send data over kind of many miles. And so just recently, we are finishing up rolling out the next version of our platform, which is very much a nationwide wireless network for device and sensor data. And it's actually quite interesting in the context of this panel because we have kind of two things going on. One is a distributed, decentralized machine network built on a gateway product, and then we're also targeting people building sensing applications talking to this wireless network. Yeah, we're excited to be on the panel.
Yeah, thanks for inviting me. Soren Knudsen with Intel. Short story, we turn sand into compute. So I think you guys are familiar with Intel. Aside from manufacturing, we really focus on three use cases: data center and cloud, PC and Chromebooks, as well as the edge and Internet of Things. So that's the part of the world that I live in. And particularly, we have a toolkit that's designed to optimize your machine learning and apply it towards video on any of our processors that are out there on the edge devices.
Fantastic. Thank you, guys. So I have a couple of questions which I'm going to ask the panelists here as it pertains to edge. And then I want to open it up to the audience. So we have two microphones, one on each side, so that you can ask any specific questions to the audience, to the panelists as well. as it pertains to edge computing. So let's get started, and maybe Willem, I'll start with you. You know, why should we care about edge? You know, if you think about connectivity, that is becoming ubiquitous. People are talking about 5G, the narrowband. So tell us why we should care about edge, and maybe give us some of your favorite use case where edge computing is really becoming relevant.
Yeah, absolutely. So for us, it's kind of been an evolution as how the product has evolved and how kind of our customer needs have evolved. In the beginning, when we were just collecting data, it's fine to not have constant. It's not as mission critical as if you're controlling the process or alerting on the process. But even still, there are Wi-Fi networks in the factories, but they're not perfect. They're going to go down. There's going to be latency. So you really need to have kind of the edge computing there to just buffer. But even when you're buffering, you need to make sure that it's 100% accurate. Because if it isn't accurate while we're buffering all that data, it is completely useless in the end. So that was kind of our first use case. And then as we started moving into alerting and machine learning on the edge, and eventually, which we're launching by the end of this year, control on the edge, then you are 100% mission critical in the process, and the manufacturing process of our customers can't be dependent on the internet. And it's not just for latency or how quickly you have to react, but edge cases like ISPs going down is a very real reality that they can't actually afford. A favorite use case, actually, that we haven't done, but that we're kind of planning on being able to solve, because we've heard this from the industry, is actually manufacturing in environments that aren't, very stable, as Puerto Rico, as an example. We've heard of manufacturers there who they were able to get power up and running reasonably quickly through generators, but they're still without internet. And so if your manufacturing process is then dependent on the internet in order to work, you're quickly out of business. So it is an absolute need to be able to leverage the edge and the cloud in a kind of hybrid environment in order to both get the best results that Industry 4.0 can do, but also maintain the criticality of a true manufacturing kind of system.
So it's not really as ubiquitous as we want
to
think, so.
Yeah, it really isn't. At least not with the right uptime.
So Sam, Pixeom has been working in various industry, retail, and others. So tell us your perspective of why should we care about edge and some of the use cases that you see.
Absolutely. So the reason we care about edge is because as you continue to add more devices, more connected things, and more importantly, more insights and more analytics, that data starts becoming so large and generating at such a fast pace that it becomes impractical to send to the cloud. We've had some customers, especially even in oil and gas, that have told us the amount of time it takes to upload 1 day's worth of data, it takes 7 days to do so by the time it gets up there. So by the time you can actually, if you're using a cloud-based or cloud-only based approach, you're already operating on obsolete data and not generating the insights you need in the time you need it. But for me personally, my favorite IoT use case, or my favorite IoT use case that involves edge is smart retail. As I mentioned earlier, there's devices, a lot of different devices and analytics and insights to keep track of. It's very people-focused and shopping behavior. But the reason it's my favorite is because, philosophically speaking, the success of this use case and enabling some of these features like tracking shopping behavior, seeing which customers are picking up which products, and correlating those together, that's all the type of insights you see on online shopping retailers. And but with the success of this use case, it enables all of the physical retailers to be battling Amazon. And I think, especially at this show, we can all get on board with battling Amazon. So.
Great. So data volume is still increasing, and if you really want to analyze and get real-time insights, you need some edge compute and edge intelligence to
absolutely
make sense of the data. Mark, what are some of your use cases, and share some perspective with us?
Yeah, so we kind of look at it from two different angles. So for us, I don't want to call us kind of edge compute skeptics, but we've been around for 5 years. If you go to helium.com, you'll see a big tagline about how IoT has failed. It's meant to kind of evoke some reactions, but some people tend to agree, some people hate us. No one's generally in the middle on that, which is nice. And so what we've seen thousands of enterprises and developers come to us over the years trying to build use cases across pretty much every single industry. And where they tend to fail is where they get too complex. So on the edge, we see success, faster POCs, more things being developed faster and kind of shipped into the field when people are just writing kind of simple programs to run on top of sensors, generally just kind of capturing data, sending it back over the wire. Now, again, we're looking at kind of small data on devices that are meant to run on batteries in the field for numerous years. And so you really want to minimize how much battery you're using. And the kind of the radio operations tend to take more of the battery. So compute really isn't that crazy, but people are trying to keep it simple. So there's a guy in the audience named Sunil from a company called Wallow, who is a Helium customer. They make a really nice, simple application that lets people do monitoring and control of swing gates for gated communities. Awesome use case. They're going to crush it. We love that sort of stuff. And I think we'll start to see kind of more complex edge computing on the Helium network, but we're targeting kind of lower data rate devices that are meant to be out there for a while. Right. One level up from that, we have kind of the Helium gateway infrastructure, which actually does the wireless network building and kind of generation. And so you can kind of call that a low power, wide area network, and we can do whole panels on what that is. But that piece of hardware, has a dual core ARM processor and runs Linux, and actually does a fair amount of computation, primarily for the operations of the network. So that is where we kind of focus most on the edge computing stuff.
It's great, and it's interesting you mentioned that battery consumption. So much of battery is consumed for RF transmission and others. We have one of our customer who does parking management, and they have these sensors which are put in all the parking spots. And he mentioned yesterday that they want those sensors to last for 10 years, the battery in those sensors to last for 10 years. And 70% of that size of that sensor is battery. And the cost is also, most of the cost is also about the battery because so much of it's spent on RF transmission. So it's an interesting.
And from an economic standpoint, if you have to roll a truck to replace a sensor even once, you're kind of blowing up your entire cost model. Exactly. So, yeah.
Great. Soren, so Intel has been working on edge gateways for quite a couple of years now, and we've been working together on this.
Right.
So share us some of the interesting patterns which you guys see.
Certainly. Talking about the volume of data, videos right there. There's so much to send and putting everything up in the cloud. And what you're probably doing, you may want to record locally and keep it for forensic purposes and to go back and to review video later, and you can keep that locally and not need to send all of that. But what you really want when you're having video is to ascertain what's going on in the video. That's the data you really want to get out of it. And so that makes it a great use case for the edge because right now, and if you look at security and where it's come, maybe it saves some bandwidth by not recording when there's no motion. But then a tree blows in the wind and you're recording it, and so can we get smarter about that? Can we get vehicle motion or can we get person motion? Right. Can we get even more on the edge and say, well, actually this person was in 7,000 frames, but this is a picture of the person. That's what we should send up to the cloud. They were here that long and this is the image. And now you're using the cloud to figure out, well, how often is that shopper coming in or that employee at the work site? And you've been able to really leverage the compute there at the edge.
Great, and you're right. Video is one of those use cases which generates a ton of data and doesn't make any sense for us to send every video frame to the cloud for processing.
Exactly, and then use the cloud where it makes sense, like, I don't know what happened in these frames. That's what the cloud's for. Let's put that to work.
Great. So gentlemen, you guys mentioned about some of the use cases, and I think it's clear now that there are, you mentioned about connectivity is not really ubiquitous, data volume, the battery consumption which you need for RF transmission. So what should customers be considering, right, when they think about building IoT solution that involves edge, right? And how do they decide what data should be analyzed on the cloud and versus on the edge, for example? So, Soren, why don't you start this time?
Yeah, well, one of the things that we didn't touch on was obviously privacy as well. Right. But you've got this compute load that you can spread across the spectrum from the sensor to the edge to the cloud. One thing I'd encourage us to think about that maybe is a little outside of our wheelhouse sometimes is also looking at the business model and who's paying for the data transmission. At the edge, if you're doing it internally, great, it's all your bill. But if you're selling a service or something like that, who's paying for the compute, who's paying for the edge device, all of that. And that might help you decide on where the load should be. Is it something that's in the cloud and there's that cost model versus in the edge and it's a one-time deployment? And you also brought up, once you have a truck roll, things get spendy. So what can you do and make it stable and last a long time? Because some of those locations, especially for video, are pretty awkward to get to if you have to switch that out. So thinking about what workloads do you want to put on the edge from those other costs and business standpoints is definitely a factor I'd think about.
Great. Mark?
Yeah, so I think when we talk to companies who either have an idea or have some sort of working product that's connected, we urge kind of simplicity and the ability to kind of go slow to kind of improve what the product does. So you're always going to want to build something on a kind of an infrastructure and a wireless network that lets you update your device on the edge. And so from there, what you can do is start with a very kind of simple application. So again, the Wallow example, monitor a gate, open a gate. There's another great company called Agulus, which is building connected irrigation control systems for farms on in the southeast of the United States. And so they've built this fantastic controller that connects to a whole bunch of different inputs, 420 milliamp SPI, Modbus, and they do very simple things. Like they ingest data and then they use, don't know if they use Google Cloud. We don't have to talk about that. But they push control signals out to switch gates open and close, and that's pretty much it. And then from there, based on what you think you can actually kind of improve upon for the customer, you can continue to make updates. So that would be one thing. And then mostly what we see is that kind of related to this, the simple applications win. Don't kind of get caught up with the idea that you have to build fancy kind of edge processing and complex logic to make it a successful application. You should do it if you need it, but it's not required on day one to ship something successful.
So simplicity is the key in terms of when you think about having the solution which requires edge as well as cloud.
Yeah, because the networks are going to get better, the technology is going to get better. Companies like Pixeom are building really nice platforms to let you kind of communicate with devices over the edge and do complex things when it comes to that kind of operations. Right. So kind of expect it to get better and build something that works and then improve over time.
So you can move all the complex processing to cloud, and as long as you're keeping your edge sort of solution simple, so you can update it over time as well as you.
Yeah, precisely. Yeah,
makes sense. Sam?
So as a software provider, our customers will often ask me, what is the minimum footprint to run our stack and our software? And we'll usually hear them say something along the lines of, oh, we're very sensitive to budget. We have this hardware in mind. Usually it's something comparable to like a Raspberry Pi or something embedded. And as our product is very low end, so we are very low footprint, so we tell them that. And then I ask them out of curiosity, what do you intend on doing? What type of workloads do you plan on running? And then they come up with a laundry list of 10 different video analytics and retail analytics to be running on a Raspberry Pi. So the first point I just wanted to bring up was maybe have realistic expectations of the workload you want to run and the hardware you want to run it on. And that's also one of the reasons I'm very excited about the Edge TPU announcement, things like that. I think there's a lot of great new hardware coming out that hopefully what I'd like to see IoT solution providers and all the customers and the ecosystem around that is to be investing in more edge processing and kind of create that balance between the edge and the cloud. That being said, Edge always has a limit. There's a resource limitation. You're going to run out eventually. So one of the key themes that I also am a big believer in is creating that seamless experience from edge to cloud and making sure that the workload can migrate very easily.
Great. And it's interesting you mentioned about budget because there was a session yesterday, and a lot of the founders of those companies have mentioned the same thing, which is you can start, as you think about building an IoT solution, if you start with a small prototype, that's fine. But as you scale up to hundreds of thousands of these hardware devices, it quickly goes out of your budget cap. So Willem, you've been looking at this manufacturing space for some time, and you figured out a way by which you can use this sort of off-the-shelf Raspberry Pi to really build this IoT implementation with edge and cloud. So from your perspective, what should customer think of? I mean, Sam mentioned budget. Is that, how would you make sure that it's still within your budget?
Well, so it's interesting because I mean we've touched on kind of the most common constraints, and in the manufacturing environment, we've actually been very lucky that those constraints aren't as prevalent. Because size, you're comparing it, you're putting it in an environment with industrial machinery or programmable logic controllers that are 10 times the size. Same thing with budget. Everything else in the factory is 10 times more expensive. Right. You have persistent power at all times, because if you don't, the factory doesn't, and so you're probably fine. Right. So the network is really the only kind of constraint you have to play with and work with, which is semi-reliable. Or you have to at least make sure that you're planning for the edge cases. No pun intended, actually. Because even if the network going down is not your problem or not your fault, it ends up being your problem because the customer can't actually use it. So for us, our kind of edge strategy is really just focused on the different personas in the factories and the workflows that they need to do, so that we can plan around like the connectivity dependency and make sure that they have a seamless experience regardless of what happens with that. So it goes into, for operators to receive alerts or for controlling mechanisms or doing predictions out on the edge, that has to happen as close to real time as possible for the operator on the edge. It's completely fine if some of the analytics and operational data doesn't happen on the edge because it's not mission critical. Right. They can go look at that an hour later when the network's back up. But for the operators to maintain their workflow, that is key. So that's kind of the bigger constraint in my mind, really planning for the SLAs and the people and their workflows.
Great. Oh, so where you have for real-time applications which operators need to know, you need to design that for edge, and rest you can sort of batch it, store it, and then push it to cloud. Great. So I have one more question for the panels, and then I would love to hear some questions from the audience. So if you have questions which you think of, please come to the microphone, and then we can ask the panels the questions, and hopefully they'll answer it as well. So folks, you've all been Google Cloud partners in some form or the other. And I think Mark, you mentioned there's one company which is not using Google Cloud yet, so we need to talk about that.
One of many. We'll get them there.
So what can, as you think about some of your use cases and the implementation constraints, what can we do, what can Google Cloud do differently or better to improve and simplify IoT building implementations? Maybe we can start with you.
I have a wish list from our engineers. No, no. You guys,
I see some of our engineers sitting there as well.
Yeah, you guys are doing great. I think I asked this specific question, and there was one thing that came up, and that was kind of device management and provisioning for non-Android things. So for Linux devices, that would be
easy.
That would be a great Christmas gift.
Great.
So the one thing I love about what Google does is they give out stuff. TensorFlow, and free. And I think that's a great way to get the community involved, get them working with it. I'd like to see you guys give out more stuff. Give out Android things. Give out even the Edge TPUs. Start introducing those to the community. The more the community gets to play with it, the more we get exposed to it, the more easier it will be to be building edge-included IoT solutions.
Great. That's a great point. And within certain limits, obviously, we can give many of these things free. But our philosophy is really about open source. And as you can see with TensorFlow, Kubernetes, so many of them, the technology which we build internally, we do tend to open source it so that we can sort of drive the ecosystem and the community around those infrastructure as well. So good point, noted. Mark, what do you think we should do better?
Yeah, so I'm a little bit torn about mentioning this. So specifically in the context of devices and Google Cloud IoT and Google Cloud IoT Core, it would be, I think, ideal for more general adoption if you could make the process of provisioning devices, specifically with the kind of hardware-based security keys at the edge, more seamless. Now, I'm torn on it because Helium has built a very nice interface to that. So we have built this thing called a channel, which lets people very quickly authenticate and provision devices from the edge with a hardware-based private key from your device all the way up to Google Cloud IoT Core. It's a great thing. But generally, I think it would be useful if there were more kind of conveniences around how that goes for people not using Helium, which maybe won't be the case forever. But that's what I would suggest.
Fantastic. So we recently, in fact, at Next, we did announce provisioning service, cloud IT provisioning, with the intent of, to a certain degree, what the use case you mentioned, which is, where you have hardware keys or you're manufacturing at scale.
Right.
How do you provisioning all the services seamlessly so that you don't have to individually and manually do for each of the device?
Oh, okay, good.
So it's working on it, but obviously love
All
to
right.
get your feedback as well.
Great to hear on the provisioning as well. When I was chatting with our engineers about it, we feel pretty good. There's training videos, the integration using Google Cloud with our products is great. So actually what I was hoping to do is maybe flip that and see if anybody in the audience has the same suggestions for any of us, and yourself included, on what we can all do to make your lives easier.